The last part of 2.4 is going to focus on special types of lines. So we're going to start with this little warm-up, and that'll kind of lead us into what we're looking at here. So we're going to start with graphing 2x plus 1 and 2x plus 5, all both on the same set of axes. So with the first one, 2x plus 1, my slope is 2, or 2 over 1, and my y-intercept is at 0, 1. And for my second one, my slope is also 2, or 2 over 1, and my y-intercept is 0, 5. So you're going to start at 0, 1, try to 0, 1, and then from that point, I'm going to go up 2 over 1, up 2 units over 1 unit, get that point, and then I'm going to draw that line. And then for the second point, I'm going to go to 0, 5, so go up 5 spaces on the y-axis, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then I'm also going to go up 2, right 1, and then I'm going to connect those points. And then the idea is taking a look back at what you notice about these lines. My hope is, and you might have noticed this before you even graphed them, that these are parallel lines. And what you notice whenever you started graphing them is they had the exact same slope. So the idea here is that you noticed that these slopes were the same. So that is your indication that these graphs, because they have the same slope, will never touch and therefore be parallel. So the last part of this lesson is looking at what we know about lines that are parallel and what we know about lines that are perpendicular. So parallel lines, here's what we know. Anytime two lines are parallel, we know they have the same slope, but they have different y-intercepts. So kind of writing that as a form, like my slope of line 1 and my slope of line 2 are the same, but my y-intercept of line 1 and my y-intercept of line 2 are different. The symbol for parallel is like two long bars, kind of closer together than an 11 and a little bit longer than that. So if you ever see that symbol, sometimes they're like slightly slanted, that is telling you that lines are parallel. Perpendicular lines don't have the same slope. Perpendicular lines have what's called opposite reciprocal slope. Opposite means one of them has a positive slope and one of them has a negative slope. And reciprocal means that their fractions have been flipped. So your slopes are opposite sign and reciprocal fractions. The one way you can check that is if you multiply the slopes together of parallel lines, they will always multiply to give you -1. My symbol for perpendicular is an upside down capital T. So you should see that symbol. And I'm totally fine with using that symbol regularly and not writing the word perpendicular because it's really long. So for example, if I know a slope of a line is 1/3, then my perpendicular slope, opposite reciprocal, would be -3 over 1, or -3. If I know I have a line that has a slope of -2/3, my perpendicular slope would be +3 over 2. If I have a slope of 4, my perpendicular slope would be opposite reciprocal -1 over 4. So any slope that is given, you can find the perpendicular slope by using the opposite sign and flipping the fraction. So we're going to practice it with a couple questions. So this is asking you to write an equation in point slope form and slope intercept form. So we'll practice all those old forms. If we know a point that it goes through and we know a line that it is parallel to. So if it is parallel to this line, what we care about most is we care about the slope. Because if it is parallel, then we will be using the exact same slope as that line. So if that line has a slope of 3, which it does, then my parallel line would also have a slope of 3. So we're going to have a slope of 3. We're going to go through the point 2, 9. So I have a slope and a point. So I'm going to use my point slope formula. Let me remind you what point slope formula is. Here's my point slope formula. So you're going to do y minus your y coordinate is 9 equals slope is 3, x minus your x coordinate is 2. Distribute so this is point slope. So if the directions say point slope, that is your answer. It wants to go further and get slope intercept. So I'm going to distribute the 3. So 3 times x, 3 times -2. And then I'm going to add 9 to both sides to get y by itself, so it's in slope-intercept form. So my answer is 3x plus 3. So that is slope-intercept form. The earlier one was point-slope form. If it talks about perpendicular, so with perpendicular, best thing to do with this is first identify the slope of the line you're given. So this line has a slope of -1. But since I'm working with perpendicular, I want the opposite reciprocal. So -1 is just like -1/1. When I flip it, I still get 1/1, but the opposite will make it positive. So I'm going to use a slope of 1, and I have a 0.71. So I'm going to go back to point slope. Y minus 1 equals, my slope is 1, x minus 7. That is point slope form. So if that's all at once, you're done there. To get it in slope intercept form, we're going to distribute, which isn't going to change anything. We're still going to be left with a 1x minus 7. You can put a 1 there. You don't have to. And then you're going to add 1 to both sides. So my slope intercept version is y equals x minus 6. So if you were to graph your original equation and you were to graph your new equation, you would end up with two lines that are perpendicular. So that is the last part of 2-4. Special types: parallel have the same slope, perpendicular have opposite reciprocal slope.